Welcome to Grammetric. Grammetric is introducing Circle SFR, the latest approach in measuring spatial frequency response of imaging devices, such as cameras used in mobile, automotive, security, and virtual reality applications. The limitations of slanted-edge SFR are well known. Camera lens distortion can cause the slant angle to be significantly lower than the 5-degree slant specified in the ISO standard. This means that the resulting slanted-edge SFR can contain higher aliasing noise, which can reduce the reliability of the measurement. In addition, the lens distortion can cause the slanted edge to be distorted, which causes a linear regression to fail. Although a high-order polynomial regression can be used, in practice, this approach requires significantly higher number of pixels to sample edge spread function. In Circle SFR, on the other hand, the contrast edge appears in a circular arc rather than a straight line, and this leads to a more efficient sampling of edge spread function. Use of circular edge in SFR, or spatial frequency response, was first reported in 2003. Since then, the medical imaging community has recently begun using this technique to characterize image sharpness in CT, SPECT, and PET devices. Circle SFR measures spatial frequency response along sagittal and tangential directions, and the results are directly comparable to lens simulation results that predict the upper boundary performance of camera resolution. Thus, it is possible to use Circle SFR to analyze the quality of a given lens sample against its theoretical limit, and also to evaluate the construction quality of a given camera, which can also reduce image sharpness from its theoretical limit. Let's take a look at a sample measurement. Here, we compare the result from Circle SFR compared with that of the slanted edge method or the ISO standard 12233. It can be observed that Circle SFR reveals two distinct image sharpness characteristics along the sagittal and tangential directions. The measured sagittal and tangential MTF results can be compared against the numerical simulation results, which show the upper boundary performance limit. By noting how far the measured MTF results are from the numerical simulation results, the system design and test engineers can draw inferences about the quality of optical components and the overall construction quality of imaging system. The measured results from the conventional slanted edge method, on the other hand, does not show an obvious trend. The MTF results are more difficult to interpret since these data points are harder to correlate with the numerical simulation results and do not exhibit any obvious intuitive pattern. For this reason, the MTF results from the slanted edge method is seldom presented as a surface plot, despite the powerful insights which can be gained by looking at MTF as a three-dimensional terrain. The 3D MTF surface plots generated by Grammetric Circle SFR are simple yet powerful tools. A good example is lens tilt. Any significant tilt or otherwise unexpected pattern in the measured sagittal or tangential MTF surfaces can immediately inform the design and the test engineers that a corrective action needs to be taken. Grammetric Circle SFR can be used with collimator-based SFR target projection. Collimator setup does not require a rotation of test chart that is commonly required with slanted edge-based targets. The circular target also allows near 100% utilization of collimator aperture, since any lens distortion along the radial axis does not alter the shape of the projected circle. Grammetric Circle SFR will be available in professional and enterprise editions as a standalone application in Windows 10 and Mac environments. Please contact sales@grammetric.com for more information, such as how to integrate Circle SFR technology in your product. Grammetric Circle SFR has been experimentally validated using ISO 12233 standard slanted edge SFR. One chart containing a printed circle and another chart containing a printed square was placed approximately 3 meters from the camera, such that an identical set of region of interest or ROI can be used in both cases. Slanted edge SFR was performed on the square chart image, and Circle SFR was performed in the circle chart image, using identical ROI definitions in both cases. This resulted in a comparison of Circle SFR and slanted edge SFR along a set of 28 unique ROI locations within the camera field of view. The result is that of the 28 locations, the highest difference in the MTF measurement at characterized 1/4 Nyquist frequency was less than 1%, and this has been traced to the limited mechanical precision at which the circle and the square charts are aligned with one another. Circle SFR was also validated with the use of simulated images based on realistic models of lens distortion. Using a simulated image from an ultra-wide 120-degree field of view 12-megapixel camera, Circle SFR reported less than 0.1% MTF error in the range between 0 and 1/4 Nyquist frequency. Above 1/2 Nyquist frequency, the observed MTF error was found to be within plus or minus 2% after an optimization of the supersampling rate. Grammetric Circle SFR will be available in professional and enterprise editions. Please check out the free trial of Circle SFR at www.grammetric.com. Please contact sales@grammetric.com for more information, such as how to integrate Circle SFR technology in your product. Thanks, and see you soon.